1 shows the parts of the electromagnetic spectrum: gamma rays, X-rays, J, visible, K, microwave, L. Which row of the table names the parts J, K, L of the electromagnetic spectrum? So I know this is radio, microwave, this should be infrared, visible, this should be ultraviolet. So J should be ultraviolet, K should be infrared, and L, so that will be option C. All electromagnetic wave can travel in a vacuum. Which of these is the same for all electromagnetic wave traveling in a vacuum? Amplitude, no. Frequency, no. That would be speed. X-rays can be useful and harmful to humans. State one way that X-rays are useful to humans. To see broken bones, that would be one. Radiotherapy, okay, we can say broken bones, to see broken bones, to use for radiotherapy. We can use that to detect crack in metal. Okay, detect means to find out if there's a crack in a metal. Detect cracks in metals. So any of this will get you that 1 mark. State one way that X-rays are harmful, okay, to humans. So if you absorb X-rays, it can cause cancer. Okay, it can cause burns, can damage cells, damage or kill cells. So there's a lot that you can write over here. A person warms their hand in front of a hot fire. Okay, you can see the fire. Use words from the box to complete the following sentence. The electromagnetic wave that the fire mostly emits, that would be infrared. These waves transfer thermal energy. Okay, because thermal energy is the only, okay, it can't be chemical. Chemical is in the muscles. Thermal energy and chemical energy are the energy stores in the option. And I know that heat emits thermal energy, so transfer thermal energy. Fire emits infrared wave. Okay, that gets us our 2 marks. A cyclist has a mass of 64 kg. The cyclist rides from a flat road to the top of a hill. So ride flat road, top of a hill. Okay, the top of the hill is 24 meters above the flat road. So this is 24 meters. Calculate the gain in gravitational potential energy of the cyclist. G is 10 and the max is 2 marks. And it says calculate, so I need to show working out. So working out will be 1 mark, my answer will be 1 mark. So the mass is 64 kg, G is 10, and the height is 24 meters. So that gets me 1 mark. And my answer would be 15,000 joules. The cyclist returns to the flat road. The mass of the cyclist is 64 kg. Calculate the kinetic energy when the cyclist is traveling at 6 meters per second. Okay, formula is given to us. Says calculate, so I need to show my working out. And this is 3 marks, so working out should be 1 mark. Answer should be 1 mark. And I know if I use the v squared, that will get me 1 mark. So Ke would be half times 64 times 6 squared. This gets me 1 mark already. Doing that gets me 1 mark. So my answer would be 1200 joules. The cyclist then uses the brakes on the bicycle to stop. Explain what happens to the kinetic energy of the cyclist. 2 marks. Explain. I need to give a reason. So I need to make a point and then give a reason for my point. So what happens to the kinetic energy of the cyclist when the cyclist applies the brake? 1, the kinetic energy will decrease. So decrease in the kinetic energy. Okay. Why? Because the thermal energy of the brakes will increase. Okay. So I have my reason, have my point. So that would be my 2 marks. Again, if the brake is going to get hot and energy is going to be transferred or lost to the surrounding. So there's a lot of things that I could say here. A different cyclist uses a motorized bicycle. The motorized bicycle is powered by an electric motor. Electric motor. Figure 3 is an energy diagram for the motor. So total energy is 24,000. Useful energy 19,000. The wasted energy would be 24,000 minus 19,000. That is around 5,000 joules will be wasted. Okay. Because this plus this should give me this. So what's the question? Oh, okay. So my wasted energy, I have already done the calculation. 24,000 minus 19,000, that gets me 5,000 joules. Okay, so 5,000 joules of energy is wasted. Calculate the efficiency of the electric motor. So if the useful energy is 19,000 and the total energy is 24,000, then this will give me 0.79. Then I have to multiply by 100 to give me a percentage. So that would be 79%. 1 mark for my working out, 1 mark for my answer. That completes the 2 marks. And it says calculate, so I've shown working. So I've shown my working out and I've given my answer. A car is traveling at 10 meters per second. The driver sees a danger and stops the car. The stopping distance for the car would be smaller if the car had more passenger. No. Had 1 tires. Definitely no. Needs a new brake. No. It's traveling slowly. Okay, yes. So that gets my 1 mark. Figure 4 shows a speed time graph for a driver stopping the car. So I can see it's at constant speed and then decelerates. Okay. Question. Using graph to find the driver's reaction time. So the reaction time. Use the graph to find the reaction time of the driver. So for 2 marks, and it says use the graph. So let's see when the driver actually reacts. So I can see that it was at a constant speed, then decelerates. So this is the time it took the driver to react before decelerating. So this, what would this be in my time? So this would be 0.6. So it took the driver 0.6. It took the driver 0.6 seconds to react. Okay, so drawing this line gets me 1 mark, and then my answer, so this would be 0.6 seconds. Figure 5 shows the apparatus a student uses to investigate how the stopping distance of a toy car depends on the type of surface. So I'm changing the type of surface, okay, and I'm measuring the time it takes to stop. Okay, describe an experiment to find out how the stopping distance depends on the surface that stops the toy car. For 2 marks, I need 2 points, and it says describe, so I need to state facts. Looking at this car, what would I need to do? I would need to, 1, release the car and measure the distance it travels on one surface. Secondly, because I'm changing the surface, change the surface and repeat the process. My last point would be, I need to record the time it takes the car to travel the same distance on the different surfaces. Okay, so that would be my investigation. So release the car, let it go down the slope, then change the surface, repeat it again, and then record the time it takes for both surfaces, for the car to travel down both surfaces. That will tell you how long it takes for the car to stop in the different surfaces. Figure 6 shows a set of results used to find the average stopping distance of the car on a surface. So test number 1, 2, 3, 4, 5. So 5 different tests. Stopping distance 0.35, 0.32, 0.52, 0.38. So this is clearly not right. State the anomalous value of the stopping distance given. So anomalous means value that is outside the range. So this would be 0.52 clearly. The rest are in 0.3, 0.3, 0.3. This is 0.5. So that's my 1 mark. Use the result in figure 6 to calculate the average stopping distance. So average mean, that is mean. So I have to find the mean of the result for 2 marks. And it says calculate. I need to show my working out. Show working, 1 mark. My answer will be 1 mark. So we don't use the anomalous for mean calculation. So I remove that. 0.35 plus 0.32 plus 0.38 plus 0.33. Divide that by the total. That's 4. That gets me 1 mark. My answer would be 0.35. That is my remaining mark. State one way the student could increase the speed of the car as it reaches the flat surface. Make the slope steeper. Okay, that's an easy way. Make the slope steeper. What do I mean by that? If the slope is like that, you can increase the steepness, so the car speed will increase. I can also say push the car, push the trolley, or pull it. So I can add some weight to pull the trolley. That'll make it to increase its speed. A car is traveling down a slope at 2 meters per second. The car accelerates for 4 seconds. The speed of the car increases to 12 meters. So this is my U, this is my V, this is my time. Calculate the acceleration. 2 marks. Calculate, show working out. So that would be A is 12 minus 2 divided by 4, 1 mark. My answer would be 2.5 meters per second squared. That's the acceleration. Quantities can be either scalar or vector. Which of these is a vector quantity? Vector has size and direction for 1 mark. Mass has size, no, not direction. Force, okay, that'll be force. Force has a size and direction. Figure 7 shows a ball bearing as it falls slowly through a clear, dense liquid. Clear, dense liquid. Ball bearing falls slowly. The apparatus in figure 7 is used to find the average speed of the ball bearing as it falls. Devise an experiment to determine the average speed of the ball. Devise an experiment to determine the average speed of the ball bearing as it falls through the liquid. Okay, devise, so I need to give or state a method. Okay, state a method that I can apply for 4 marks. So I need to state at least 4 points, 4 methods. I need 4 methods. That'll get me 1 mark each. You should include any extra apparatus, the measurements you would take, how you would calculate the speed. Okay, now I know that speed is distance divided by time. So I need to calculate distance, I need to calculate time, and then find the speed. So what would I say my first point would be? Measure the distance. Measure the distance. The ball will fall. Okay, what am I using to measure the distance? Using a meter rule. My second point would be record the time it takes for the ball to fall. Using, what am I using to measure the time? I need to use a stop clock. Using a stop clock. Okay, then once I have my distance, I have my time, I need to apply use speed is equal to distance divided by time to find the speed. Okay, now I need to repeat the steps and calculate mean speed. So that will be my 4 steps to carry out the experiment. A student thinks that the ball bearing falls through the liquid at a constant speed. Explain how you could develop this experiment to determine if the ball bearing falls through the liquid at a constant speed. So explain how you could develop the experiment. So for 2 marks, you may draw a diagram to help you. So what I could do, I have this tube and I have my ball bearing. So what I could do is to have my starting distance and then put a mark at different distances. Okay, this distance D, okay, should be the same. Okay, then I have to measure the time it takes to fall from this to this, from this to this, from this to this, from this to this. So if it falls at the same speed through these distances, then I would say that would be a constant speed. Okay, so what I will write is add marks on the boiling tube at equal distances. Okay, that's my first point. My second point would be measure or record the time it takes the ball to fall through the distances and compare the time. Okay, so that will be my step to develop the experiment. The ball bearing is now dropped through air. The initial velocity of the ball bearing is 0, so u is 0. Acceleration of the ball bearing is 10 meters per second squared. Distance is 1.5 meters. Calculate the velocity of the ball bearing when it falls 1.5 meters. Velocity of the ball bearing, so that is, I'm looking for v. So I'm looking for my v. So v squared minus 0 squared is 2 times acceleration is 10. My distance is 1.5 meters. Okay, calculate, I'm showing my working out. So v squared would be 30 meters per second. So v would be the square root of 30, which is 5.5. So my answer here will be 5.5. So I have my 1 mark. Figure 8 shows part of a wave. So height in centimeters, distance, the peak of the wave is this. Okay, use the data to calculate the wavelength of the wave. The wavelength would be so if half of this wave took 10, 11, 12, 13, 14, so half of the wave is 14. 1/2 wavelength is 14 centimeters. So one wavelength would be 14 times 2, which is 28 centimeters. So my wavelength will be 28. Okay, that's my 2 marks. I've shown my working out. I've written down my answer. Okay, half the wavelength is 14. One wavelength would be 14 times 2, it's 28 centimeters. 1 mark, 1 mark. Figure 9 shows a student sitting on the shore of a lake, watching ripples on the surface of water moving past a toy boat. Toy boat, ripples, okay. The student has a stopwatch. Describe how the student could determine the frequency of the ripple on the lake. So frequency is number of waves passing a point in 1 second. So 1 second, okay. And it says describe, so I need to state facts. Okay, facts. For 3 marks, I need to state 3 facts. So what could the student do to measure the frequency? Okay, so I could say record the number of waves passing the toy boat in a specific time. Okay, number of waves passing the toy boat. So the toy boat is our point in a specific time. Use frequency is number of wave divided by time. That gives you the number of waves per second. Okay, so that's my marks. The speed of a water wave is 1.5 meters per second. The frequency is 0.7 hertz. Calculate the wavelength. So wave speed is frequency times wavelength. So I need to rearrange the formula. I put that in a triangle. This is divide, this is multiply, and this is f times. So f will be here, wavelength will be here, so v will be here. So if I'm looking for wavelength is v divided by frequency, and the v is my wave speed, that's 1.5. Frequency is 0.7. So my wavelength would be 2.1 meters. So I've shown my working out. I have my answer. That gets me my 2 marks. Water waves are transverse waves. Describe the difference between transverse wave and longitudinal wave for 2 marks. And I need to state facts. Okay, I need to state 2 facts for 2 marks. So I can say my first point will be in transverse wave, particles vibrate perpendicular to energy transfer direction. Okay, I can say that. I can say in longitudinal wave, particles vibrate parallel to the transfer of energy direction. So that's my 2 marks. Sound wave travels at 330 meters per second in air. A student uses a flash of lightning. The student hears the sound of thunder 4 seconds later. Calculate the distance from the student to the flash of the lightning. For 2 marks, calculate. I need to show working out. Okay, so distance is x. So x will be, my v is 330 meters. My time is 4 seconds. So distance would be 1300 meters. So 1 mark, 1 mark. This question is about radioactivity. Alpha, beta, and gamma are 3 types of radioactive emission. Which statement describes all of this radiation emission? So ionizing and emitted by stable nuclei. Radiations are emitted by an unstable nuclei. So ionizing are emitted by an unstable nuclei. So that will be this. So they have to be unstable to emit a radioactive emission. so they can become stable. Fluorine-19 has a stable isotope of element fluorine. The element fluorine also has several radioactive isotopes. Describe one similarity and one difference between the numbers of particles in one nucleus of fluorine. Now, I know that isotope is same number of proton, different number of neutron. So what I have to write now, my similarity will be same number of proton and different number of neutron. That gets me my 2 marks. Describe. That's the fact. Figure 10 shows a Geiger-Müller tube attached to a counter. The GM tube is used to measure the activity of a source of beta radiation. There is an aluminum sheet between the beta source and GM tube. The counter is switched on and after 1 minute shows a count of 268. The aluminum sheet is taken away. The counter is reset to 0 and then switched on again. A new count rate is taken for 1 minute. Explain why the new count rate is greater than 268. I know that aluminum sheet stops beta particles. So if I remove this, the count rate should increase. So 2 marks. Explain. I need to give a reason. My point will be the count rate increased because they removed the aluminum sheet. Increase in count rate is because the aluminum sheet was removed, so no beta particle was absorbed, meaning that more beta particle reached the GM tube. Okay, so my reason, my answer, my point, my reason. The beta source is then also taken away. The counter is reset to 0 and switched on again. The new count is taken for 1 minute. Give a reason why there would now be a reading on the counter. You give a reason, and that reason will be because of the background radiation. So that gets me 1 mark. State the SI unit for the activity of the radioactive source. The unit for activity is becquerel. That's for 1 mark. Exposing people to radioactive sources can be dangerous. Exposing people. Describe the dangers of exposure to radioactive sources and what can be done to protect hospital staffs when they are working with radioactive sources. For 6 marks, describe. So that's state facts. Okay, so I need to state 6 facts. So 3 dangers and 3 protection mechanisms. So 3 dangers will be radioactive sources. Radioactive sources are ionizing, so they may cause cancer, or they may kill or damage cells. You can also add they can cause DNA mutation. So these will be dangers. Okay, now my protection mechanism. Hospital staffs can use tongues to carry radioactive sources, okay, instead of using their bare hands. Okay, another protection mechanism could be use lead containers to store sources, because lead can stop all the sources. It can stop sources like alpha, beta, and even gamma. Okay, lead can stop all 3 of them. Another way could be for them to stay at a safe distance from the sources. Okay, another way could be wear or stay behind a shield or wall. Okay, when giving out treatments. So there's many things that we could say for protection. Okay, so choose any 3 and write. If you have found this video useful, please like and leave a comment. Subscribe and share with your friends. The aim of the video is to help you. Until next time.